Well, welcome to Lesson 4 of Chapter 8. We're going to work on solving equations where we have the variables on both sides of our equal sign. And the rules are pretty much the same. We just need to combine our like terms and then work on getting our variable on one side and all the constants on the other side. So here's an example. We're going to jump right in with how to solve these equations. So this one says solve 8 plus 4d equals 5d. Well, we have a d term on both sides. These are like terms. So we need to get those together. We can do that by subtracting 4d from both sides. And when we do that, we get 8 is equal to d, and it's already solved. So that was only one step. In this second equation, we have n's on both sides and we have constants on both sides. So this will take us a couple of steps. Usually I try to get the n terms, I try to move the smaller one. So since 6n is bigger than 4n, I would subtract 4n from both sides to keep my variable positive. So we're going to go ahead and subtract the 4n from both sides. And as you can see, that's going to go ahead and make that term drop out right here. So 4n minus 4n is 0. And then when we go ahead and rewrite that, we get 2n minus 1 equals negative 5. Be careful with your signs, your negative signs. To get rid of the minus 1, we need to add 1 to both sides. So we're going to go ahead and do that. And again, our 1's add to 0, a minus 1 and a plus 1 add to 0. So we get 2n equals negative 4, and dividing by 2 on both sides, n is negative 2. Here's a couple for you to try. This is a good time to pause the video to see if you understand. Try to work these 3 problems out, and I'll work through those with you when you come back. Alright, let's take a look. On the left-hand side, we have 8a equals 5a minus 21. And I'm going to work vertically. I prefer to work vertically rather than horizontally. So I'm going to subtract 5a from both sides. Okay, so I always try to get the bigger variable by itself. These now add to 0. Here is my equal sign. And on the left side, 8a minus 5a is 3a. And I still have that positive 21 over here. To get a by itself, a is being multiplied by 3, so I need to do the opposite, which is to divide by 3. But whatever we do on one side of an equal sign, we must do on the other. So the 3's, anything over itself is equal to 1, and we're just left with a. And 21 divided by 3 is 7. In the middle, we have variables on both sides. I would start by getting my variables together. So I'm going to subtract 3x from both sides. The 3x's drop. Okay, they add to 0. I still have this minus 7. And then bring down your equal sign. 8x minus 3x is 5x. And we still have a plus 23 over here. Well, remember our goal is to get this x term by itself. So the next thing that has to go is that 23. It's being added to the x term, so the opposite is to subtract it. So I want to subtract 23 on both sides. And since I'm working vertically here, these are going to add to 0 now. They drop out. 5x is still there. Here's my equal sign. And 7, negative 7, and negative 23. Same sign. So the numbers will be added. And we get 30. And they're both negative. One more step. X is multiplied by 5. To undo multiplication, we use division. Whatever we do to one side, we must do to the other. 5 over 5 is just 1, so we have 1x, or just x, equals negative 6. Excuse me. Alright, let's do the third one. Now this one has a fraction in it, so this one's going to be a little bit more difficult. So let's do this. Let's get our constants together first on this one. I'm going to move the 12 over by adding 12 to both sides. And lining those up where under the like term, the term that's a like. Okay, so the 12's drop out. And on the left I have 7g is equal to 3 plus 12 is 15 plus 7/3 g. And you have a couple of options here. You can leave it as a fraction or you can write it as a decimal. Excuse me. I think what I'll do in this example, I'll leave it as a fraction. So let's go ahead and subtract minus 7/3 g from both sides, minus 7/3 g. And let's just see what happens here. Not sure how ugly this is going to get. I think it'll be okay. So these now add to 0. Okay, they drop out. I still have a 15 over here. And that is equal to, we need to figure out how many g's we have here. Well, 7/3 g, right? That's really, I'm going to do some extra work over here on the side. I'll do this in blue. Well, let's do it in black because I haven't done any in black. 7/3, right, is really 2 1/3. Okay, 3 goes into 7 twice, and there's 1 left over. So we have 7, and we're subtracting 7/3, or minus 2 1/3. And both of these are g terms, so I'll just put the g's out there. But we don't have any thirds to take away here, right? So I'm going to change this to a 6 3/3, right? 3/3 is still 1 whole. So I just borrowed 1 from the 7 and wrote it as 3/3 rather than leaving it as a whole number. So let me show you how that would look over on this side then. I'm going to change the 7 to 6 3/3 g, and then I want to subtract from that 2 1/3 g, and see what I get. Okay. Now I'm not doing this to both sides because I already did it to this side and have my result. I'm still working on the left side. So how many g's do I end up getting? Well, 3/3 minus 1/3 is 2/3, and 6 minus 2 is 4. Now the question is that a positive number or a negative number? Well, since the 6 was bigger, then my answer will be the same sign as the 6, so that's going to be a positive 4 2/3. So we have one more step. We need to get rid of 4 2/3. And how many thirds is that? If I were to write that as an improper fraction, I would multiply 4 times 3 and add 2. So that gives me 14/3 g equals 15. Well, how do we get rid of that 14/3 if it's multiplied? Well, remember, the way we get rid of that fraction is to multiply by the reciprocal. So this is where all of those skills we learned in a previous chapter with fractions come in handy. But whatever I do on one side, I have to do on the other. I need to multiply by the same fraction, 3/14. And so now I'm going to put that 15 over 1, okay, just to make that more clear that we can write that as a fraction as well. So what happens to our 14 and 3? Well, 14 and 14 cancel, and they become 1. 3 and 3 cancel and become 1. But I still have that g right there. So I have g is equal to, and now I don't have anything that's common between 15 and 14, so I'm going to multiply this out. 15 times 3 is 45, and 1 times 14 is 14. And one more step, okay, g equals, how many times does 14 go into 45? Don't have a calculator with me, so I'm going to have to do this the long way. And I think it's 3 times. 3 times 14, I believe, is, let's see, 12, yep, 42. And there's 3 left, 3 3/14. So that should be our final answer, 3 3/14. That one took a few steps. Cell phones. A cellular phone provider charges $24.95 a month plus 10 cents a minute for calls. Another cellular provider charges $19.95 per month plus 20 cents per minute for calls. For how many minutes of calls is the monthly cost of both providers the same? Well, the thing that's going to change or vary in here is the number of minutes, okay? So we're going to let M be the number of minutes. So the first company is going to charge you $24.95 plus 10 cents times every minute. The second one would be $19.95 plus 20 cents for every minute. Okay, now you want to get your like terms together. Let's go ahead and solve this one together. So I would take and subtract 0.10 m from both sides. 0.10 m. When we do that, they drop out over here. And I get $24.95 equals $19.95. And what do we get over here if we're adding these together? Whoops, I'm subtracting this one, right? So 0.2 minus 0.1 is going to be a positive 0.10 m. Okay? So we've got the m's together. Now we need to get the constants together. So the next thing I'm going to do is I'm going to subtract 19.95. Whatever I do on the right, I must do on the left. Okay? So let's Draw our line. These now add to 0. Here's my equal sign. This is 0.10 m is equal to, what do we get here? 0, 0, and we got to borrow this one, so that looks like $5. Well, we have 0.10 m is equal to $5, so let's divide by 0.10 on both sides. 0.10. So these cancel, and I have m is equal to $50. Okay? The length of a flag is 0.3 feet, less than twice its width. If the perimeter is 14.4 feet longer than the width, find the dimensions of the flag. Well, this one's pretty complicated, isn't it? So let's let our variables for width and length be this. We're going to reference we're going to write the length in terms of the width. Okay, so it says the length of a flag is 0.3 feet less than twice its width. We're going to let the width be W. So then down here the length would equal 0.3 less than twice the width. So hopefully that makes sense. Remember that less than is the one you can't write it in order. It has to come after the next thing. So this 0.3 less than will be after the twice the width. That's why it's written that way. So then if we write the formula for the perimeter is the width twice, the width plus the width, plus the length plus the length. Well, now let's substitute for L right here, this amount right here. When we do that, here's what we get. Okay, each of these is the length. We know that's equal to, it says that if the perimeter is 14.4 feet longer than the width. So there's 14.4 longer than the width. Find the dimensions of the flag. So what I would like you to do is solve this equation, find out what W equals, so do all your steps here, and you're going to get W equals a number. Once you get that number, plug it in over here because this is what the length is equal to, and then get an answer for what the length is equal to. And bring that answer to class and we'll talk about that. See you next time.